Hey everybody, Donnie here, and today we are going to talk about constructors. Hopefully this should be pretty quick because we just finished methods. And a constructor is basically a specialized type of method that you've actually been using all along and haven't really known it. So let's get right into it because I want this to be quick. I've provided you here with the code examples both on GitHub for Visual Studio and on .NET Fiddle, heavily documented and undocumented, which I'll be going over in this video. So if you want to follow along with the code, you can just click on those. And as soon as I'm done with this video, you'll be able to click on this right here. Or, I mean, you wouldn't be here if you didn't click on it. So, okay. I think I will start with Visual Studio. So I added part 9 constructors. Real quick, I just want to get out of the way that I added this helper class called IO because I didn't want to mess around with input output. I wanted to make my life easy. So if you see IO dot write or write line or wait, it's just my own customized version of the console write lines. Anyway, into the actually let me start with the class. Let's start with account. I think this is definitely a start. So I have all this documentation here. I'm not going to read it all, but I will leave it on the screen so you can read it. But I suggest you read it after you just listen to what I have to say, because I'm going to kind of paraphrase it a little bit more succinctly. Um, this right here is a method. Um, so when we talked about methods, we went through every variation, and one of the variations of the methods that we talked about was a void method that took a parameter and used that parameter to change the value of a member variable internally, a private internal member variable. We said that this was encapsulation. We said that it was mutating the state of the object, changing a value inside the object. We also said that it was kind of forming a public interface by allowing the method to be something visible on the outside of the object that's easy to use, but might internally be pretty complex. And we went over like the microwave example of that with the buttons on the front and the complexity inside of the machine. So in this case, when we were doing set methods, we would say public void, in this case, we would say like set account number, and then we would do it almost exactly like this, pretty much exactly like this. Actually, let me just write it so you can see it. Public void set count number, string count number, and then we would say this dot account number equals account number. Whoa. Why am I not? Why am I not getting IntelliSense? It's in a bad mood. All right, don't do that. That hurt my ears. Okay, so that's what we would normally do to allow public access to be able to change this. Now you'll notice that these look suspiciously similar. There's only, if you forget about this for a second, I'll put it back. But if you look at these two methods, these look suspiciously similar. And that's the reason why I told you that learning constructors is going to be easy, because you've already done pretty much the same exact thing in a slightly different way. A constructor is almost the same as a set method, almost exactly the same actually. There's only one tiny difference, and that's a couple of things that are built into its nature and also the timing of the invocation. So let me explain what I mean by that. So while with a normal set, we would, in our main program, do something like this. We would say, account A equals new account, and then we would say A dot set account number to, whatever. Blah, blah, blah. So that's the way we would do things. And I think I was hinting at this all along that this is cumbersome because if you have like 5 different member variables that you want to initialize every time you create an object, then that's a whole bunch of lines of code, right? You have, all different obviously, but it would start to look like that, and that's no good. So um, actually, all along, and this should be the giveaway, all along you've been doing this. The moment you do new account itself, when you so there, we've talked about new. And I've told you that new creates memory. We've seen it with arrays and we've seen it with objects, and we know that it returns the address of the either array or the object that it's created because it's on the right side of the assignment operator. It takes that address and it assigns it to the variable. And we know that variables are just references to, if they're not primitive, they're references to complex objects like arrays or objects. The only thing that I didn't tell you is that this is literally invoking a method. And the reason that you couldn't tell is because, and I'm not making this up, it's invisible. So um, I want to show you something. Um, oh, I'm going to do this. Okay, so this right here is weird for two reasons, and I have that actually have the two reasons written right here. One is the name of the method is the same name as the class, and the other weird thing is there's no return type. So that is exactly what a constructor is. So that's the slight difference between the first difference is just the very specific syntax that identifies this method as a constructor. In C Sharp, I really hate it, but that's the way it is. It has to be a method with the same name as the class, and it cannot have a return type. Um, and this is always there, actually. That's why we've always been able to say new person, whatever. So if we don't specify a constructor at all, if we just create a class, like a totally blank class, say like this, if somewhere else we had like class blah, and it was just like begin and end, to be honest, um, it's actually, inside of it, it would be like public, it would be invisible, but we would still have the ability to create an object of that type. So we would be getting this method for free, invisibly. That's called the default constructor. So if you don't write a constructor, you get the default constructor for free. So we've been using the default constructor every single time we've been instantiating objects. And that's why we've been able to do this, because that is using the default constructor. So all along we've been using the default constructor, we just didn't know it because we couldn't see it. Um, so we'll start off by me actually putting the default constructor in there. It wasn't there to begin with, and I'm going to take it away again for a very specific reason. It's pretty important to understand that once you define any constructor, that which I just said, getting the default constructor for free goes away. It gets rid of it. If you define any, I'll repeat that more clearly. If you define any constructor whatsoever, you do not get the default constructor for free anymore. So right now I've implemented two constructors. Like, remember what I said. If it's a method with the same name as a class, which both these are, and there's no return type, which both of these are, then they're constructors. So I have two different constructors. And just like in methods, if you have two methods with the same name and different parameter list, that's just an overload basically of the same method. Um, so not focusing too much on overloading because we covered that last week with methods, but I want you to understand that if you look at the main program here, right here, what we've done is, so in the past we would do this, account A equals new account. So this is the first thing that I want you to understand, is that by not by by defining my own constructor and not redefining explicitly the default constructor, we lose the default constructor. That is the first thing you have to understand. So in essence, this code is the core of what you need to understand about constructors. Like if you want to say that you've learned the basics of constructors, this is it. So what it is that by coding this constructor, and once again, I've implemented a method that has the same name as the class and no return type. So automatically, um, the language knows that that means this is a constructor. But by defining this constructor, one, I've wiped out the default constructor, so this will no longer compile. It'll say there is no argument given that corresponds to the required formal parameter. See, it's basically saying it can't find any version of a constructor that matches this signature. Um, Even though it was invisible before, it was there. but by defining a new one, we've kind of said, you know what? I'm going to define. I'm not going to use the default constructor. I'm going to define my own constructors. And sure, if I wanted the default constructor in addition to the new one that I have, I could put it back in like that, and all my problems would go away. That would compile just fine. But that's the first thing. There's two things basically. So the first thing is understanding that the default constructor was always there, and by defining your own constructor that's different than the default constructor, you're starting over from scratch, and that controls the way that you instantiate objects. Because by saying this is now the constructor, or one of the constructors, in this case there's only one constructor, I'm saying in English this says you cannot create an account unless you provide the account number. And that's why this does not compile anymore. And that's why these two lines of code they look a little different, because instead of having a second line of code that says first account dot set account number to this, we have it all basically in the same line. And it's, I would say, objectively better that the constructor is controlling the initialization of the member variables, not just because it reduces the lines of code, but also for the same reason that we talked about methods being superior before, because it gives you control to change what this is doing inside of the implementation. Like for example, I mean, I don't have to say for example, I could just go all the way back to the way I had it at the very beginning. For example, I wrote this line of code in there for that exact reason. So without this line of code, all this constructor would be doing would be saying, oh, okay, they gave me the account number, so I'll set the account number, and basically you can't create an account that does not have an account number. This ensures that you cannot just say, new account. This ensures that you have to give it the account number, which you do right here. So it's just that you can do a lot with a constructor. You can write any code you want in it, but it's 9 times out of 10 the way people use it is just to initialize the member variables inside of the class, and you'll see that as we go. However, I did want to, even though it's like I said, even though it's maybe 1 time out of 10, there is sometimes that you want to do things, write other code inside of the constructor. So this would be an example of it. And if you remember when we were talking about get set methods and private member variables, we were like, why would we want the member variables to be private? Why can't we just use public variables? And I used the example of like, if your boss came to you and said, I want to do something every time this variable gets accessed or changed, you would be powerless to do it without making a breaking change. But here I could just slide in this line of code into the constructor, and the people using it would be none the wiser. They would get the new version of the account compiled code, and it would just start happening. It's not a breaking change because they wouldn't need to change their code here. It would be the same. It's just that the way that the constructor was behaving would be a little bit different. And that's what I actually wanted to show you. I mean, if you see the first 2 lines of code in the program, example 1, are just these 2 lines of code. So it's literally just creating 2 accounts. And since that line of code is in there, that's the second aspect that you have to learn about constructors, is the timing. And hopefully it's self-evident that the timing is it is invoked upon instantiation. So it's invoked right here. I'll put a debugger on it the first time just to show you. So let's see. we are on there, so I'm going to hit F11. It's going to dive into the constructor. So we're on line 25, and it's saying, okay, assignment operator. On the left side, we have a reference to an account. So on the right side, I better have an account. And it is, but it has to create it first. So it's like, hold on a second, I need to create this account by calling the constructor. And then, when the constructor is done, I'll come back and I will return and I will replace everything on the right here. I will replace all this with the memory address of the newly created object. But first, I must dive into the constructor to create said object, because obviously the class is the only thing that knows how to create an account. So here we are inside of the constructor. And by the way, I'm not sure if I mentioned this. If you want to like trace where you've been, like how you got here, when you dive into methods, you could always go to the debug window and attach to, or sorry, and show the stack. Let's see, where is that? Debug windows, breakpoints, blah 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 blah. Locals, call stack. Where's the call stack? Oh, there it is. So the call stack right there. The call stack is basically the trail of breadcrumbs that shows where you were and how you got here. So we started here on line 15, which took us to line 25, and that invocation took us into the constructor where we are now. So just a little debugging help. So here we are, and obviously we've passed this value 1, 2, 3, 4, 5, 6, 7, 8, 9 from the main program. And normally, this constructor would just be like, okay, we're going to take that value and we're going to save it in the private variable, just like we were doing before with our methods. But in this case, I'm saying something else. I'm saying like, okay, every single time I create an account, it's just going to print that out to the screen. Just going to bypass that because it's just print line stuff. So even before, I have not yet even got out of this method, and I already said account number 1, 2, 3, 4, 5, 6, 7, 8, 9 has been created. So now, at this point, the object is created. It goes back to here, and at this point, it has the object and its address to set to first account. So first account will no longer be null once I move from line 25 to line 26. So now first account is populated with the account number 1, 2, 3, 4, 5, 6, 7, 8, 9. So two things happened. And like I said, nine times out of 10, it'll just be one thing. It'll just be initializing all of the member variables. But in this case, we went the extra mile and added some code that didn't have anything to do with setting the internal values. It just printed something. So that's why example one is the simple case. Actually, I think example one might take the longest to talk about because I had to explain all of the explain the nature of the constructors. So just quick recap, and I'll do the more complicated code quicker if that makes any sense. Quick recap. One is that a constructor is just a method with the same name as the class and no return type. So as you can see, as you'll be able to see as soon as I move on to the next class, you can have as many of them as you want, as long as they don't have the same signature. Like I can't do another one that just takes a string. That won't work. And if you want the default constructor still there, you have to put it back in. So, whoa, that's a count. So I guess there's a preliminary thing and there's two aspects of it. The syntactical aspect of it is that it has the same name as a class and it has a no return type. And the two aspects of it that you have to understand are that one, the timing of it is such that it happens exactly when any instance is created. So anytime you see new account, that is calling the a constructor. You can have more than one. In this case, the constructor. So anytime you see new account, that is invoking this code right here. just like a set method. It's passing the parameter and then it's doing whatever you want, usually just setting the member variables. And the other thing you have to understand is that you don't have to only use it, even though it's commonly used to set the to initialize the member variables. You can write any code you want in here. I mean, like I keep saying time and time again, the language doesn't force you to be logical. It has loose rules, but it doesn't, it can't force you to make a program that makes sense. So you could write a bunch of code inside of the constructor that has no business being in the constructor, right? So you want to think to yourself, logically speaking, I would say you want to think to yourself in your constructor, first of all, like, do I want to have any rules for when I create accounts? In this case, I'm clearly laying down a rule saying, hey, if you create an account, you have to provide me with an account number. That's the first one. And the second one is like, what actually do I want, to always happen when an account gets created? And similarly, in this case, I'm saying, well, anytime an account gets created, first of all, I want the account number to get set based on what they told me it was. And I also want to print out to the screen that an account has been created. So that's this as in English. So now going on to the little more complicated one that I think I can get through really quick actually, now that I reiterated the important points. That's it. Basically, there's really nothing else to constructors other than everything I just said. The only thing I did here was I overloaded a little bit. And by overload, I think I already just said, and I think we covered last week, um, same method with a different signature. So here is the default constructor, no parameters. Here is a constructor that just takes the age and sets the age. And here is this is, like I said, 9 times out of 10, this is the type of constructor you'll see because a person has a name and an age, so the constructor takes the name and an age. So, usually if a person has a name and an age or whatever, it'll be like, well, okay, a person has a name and an age, therefore when you create a person, you have to tell me what the name and the age are, because I don't want to create a person that doesn't have a name or an age. So if we go back to the main program and see the way it's used down here, this is the particular constructor that we were just looking at, where the first parameter is a string name and the second parameter is int age. So as you can see, this looks a lot nicer than 3 lines of code saying like, new person and then person3.name equals Donnie and person.age equals 43. So it's like, constructors are really nice for initializing values inside of the objects that you instantiate. They're also really nice for doing things that you need to happen every time a person is created. A really great example that I usually use would be, let me do it on the simple one here. So it's like, well, what could possibly always happen when I create a new account? Well, what if I have a public static int count? So remember, there's just one count. So this would be like, how many accounts are there in the running program? Well, I could just put that in the constructor. So remember before we were like tracking down all the new statements, and after each one of the new statements, we were where's the program? So like after every time we create a new person, we would say person.count plus plus, new person, person.count plus plus, new person, person.count, person.count plus plus. Now we can just literally put it right here, person.count. Hey, oh, it's count, sorry. Count.count plus plus. So that will actually perfectly increment that number every time. Automatically it will run that every time an account is created. Since this is the only constructor in the class, it will be impossible to create an account without using this constructor. Therefore, that number will always represent the amount of accounts that have been created. So there's an example. There's endless examples I could give you, but that's just more examples of code that you might want to put in the constructor. But as I said about 10,000 times already, usually it's just a series of, here's the parameters, set the member variables to the values of the parameters. And you see that more prominently right here. This is the pattern you're going to want to memorize. This is the pattern that's this is the only pattern you're really going to need to know for this class. I'm not going to ask you to write extra code inside of the constructors. I'm only going to ask you to use them to initialize the member variables. That goes for the assignment and the final exam. So either take a mental note of this code right here and other examples that I give. Actually, examples that I gave that are over here on the board from last year, or um, we can go over more in class or on Blackboard. So it's a one. It's usually a one-to-one correspondence. There's two member variables, so there's going to be two parameters on the constructor because I need to initialize those when I create an object. Simple as that. Uh, the reason, the thing that I did different in this class person was I made three overloads. So this one takes no parameters, this one takes an int, and this one takes two parameters. So in the main program, you can see all three being used. So this is a different constructor than this, which is a different constructor than that. So it will dive into the correct one based on the signature. That's why I keep stressing the importance of the method signature. That allows it to find the correct method body, the correct method implementation to call. And I think I'm done actually. I think that's it. The .NET Fiddle code looks similar. I'll show you the minified version just because it doesn't have any comments. Looks a lot prettier. So believe it or not, this is all the code that we just went over. It's all right there. And if you run it, it'll say press any key. Oh, at first it's down here at the bottom. It's the last line. Where is it? I'm looking for something that should be like really obvious. Oh, right, of course. I just told you I didn't even. So this right there, line 63 and line 64. So those, just by nature of the code inside of the implementation of the constructor, printed out those first two lines, and that printed out the press any key to continue. So I'm gonna do that, and then I just had this loop where the purpose of this code is just to show you that you don't always have to, when you do a new object and call the constructor, you don't always have to store it in a variable. You could treat this as just a value. See, I'm creating an array, and I'm just saying here's a new object, here's a new object, here's a new object. So you could also like pass any one of those as a parameter um, if the type is correct. So you don't always have to use this form as something that's on the right side of the assignment operator. It's basically a value. It's the memory address of a newly created object. So as long as you understand that's what the value is, you can use it in any context where a value of that type is required. Yeah, and then I just have like a little loop there that goes through the array that I just created and shows that I can get the values that I just put in. And then the last one is the interesting one where I had the three different constructors. The first one, I didn't give it any initial values, so it says my name is blank and I'm 0 years old. When I just gave it the age, my name is blank and I'm 43 years old. And when I gave it both, it said my name is Donnie and I'm 43 years old. So there's three different constructors, as you can see here. So first constructor, second constructor, third constructor, those three. So that's it. I think I'll just leave it at that. See what their reaction to this is. Hopefully, if you learned methods well, hopefully this should be a no-brainer. I mean, the only thing that's weird is this syntax in C#. I hate that. I mean, I'm trying to I'm trying to think of other languages where it's better, but it's hard because all of them are. um, The only one, Java and C# are the same. Java and C# are both, create a method with the same name as the class that has no return type. I really don't like that. I don't think it's intuitive. It reads weird. For example, like in Swift, the constructor is always just a method called init, and I find that much more intuitive. So it's like, I don't know. It's just me. So yeah, I think I'm done. I'm gonna leave it at that, and I will try to make a really easy assignment. We only have a week and a half before the final, so I'm gonna try my best to make these last two assignments super easy to give you guys more time. Um, yes, I will see on Thursday if anybody's able to watch this by Thursday. I'll see how well it was received. I'm kind of in a hurry if you couldn't tell, so I may end up making this the voiceover for this video again at the end of the semester for the next semester. But all right, well, I will talk to you guys on Thursday, and if you have any questions, let me know on Blackboard as usual. All right, bye.